Hey guys, welcome to the week 12 lecture video. So in this video we're going to look at kind of rewinding a little bit back to week 10. We're going to talk about fasteners, and I'm going to slow down a little bit and show you guys some tips on bringing fasteners into your assembly models now that we know how an assembly works. So before we get to that, I want to go ahead and talk about the homework assignment for this week, which is going to be a little bit different. So your homework assignment for this week, if you go to week 12 and click on the week 12 homework assignment instructions, you're going to see is basically to start working on your final project. Now, at this point, you're probably thinking, what final project? You didn't tell us about it. So if you guys go to the final project folder, that's going to be the bulk of your work for this week, is to start working on your final project. And I've described all of the information you need to know about the final project in a separate video if you go down below. So if you go down to the final project folder, I've got a separate video for you here in Ivy Learn that describes the final project, shows you some examples of past final projects, and also gives you some tips for success and talks about the things you need to do and the things you need to turn in to complete your project. So what you're going to notice is that for the rest of the semester, you're not going to have very many weekly assignments, that from here on till the end, most of the work that you need to complete as far as doing 3D models relates to your final project. So we may have one more weekly assignment, but most of your assignments week to week from here to the end are going to be to continue working on your final project. So when you get done watching this video, you definitely want to go down and watch the final project video that's in the final project folder in the modules button, because that's going to be the bulk of your assignment for this week. So make sure you check that out after this video. So going back to week 12 now, we kind of mentioned the final project. So to help you with your final project, I want to give you some tips on using fasteners, because whatever you choose for your final project, chances are it's probably going to have some fasteners in it. And while in week 10, I think we talked about fastener types and fastening methods, I want to look a little bit more at using the McMaster-Carr website, using the Content Center and Inventor, and then I want to show you something cool you can do in an assembly file called a bolted connection. That's kind of neat, which probably is a little bit quicker than either of them. So if you want to pull up the week 12 lecture notes, I'm going to refer to those a couple times. But I do have a file you're going to want to open up in Ivy Learn. So if you go to the Autodesk Inventor sample file in the week 12 folder, I'm going to go ahead and download that thing. It's just basically, it's like a flat plate. It's got a bunch of holes in it that we can use. So if you download that and open it up in Inventor, you're going to see that. So we'll take that and we'll kind of reference that. So just for the purpose of knowing ahead of time, this plate is 6x6, and it has a bunch of 3/8 inch holes that are 1 inch on center. Okay, so just kind of a scale reference there. So when we talk about bringing in fasteners, there are some different file types we need to talk about really quickly. So you probably at this point know our different Inventor file types. We haven't talked about IPNs yet. We'll probably do that next week, but that is that's your presentation file in Inventor. But hopefully at this point you know about part files, drawing files, assembly files. We'll talk about presentation files next week. These are all native Inventor file types. There are also different types of 3D file formats that are not native, meaning that they don't go just to Inventor. They can be used for any 3D modeling program. So examples of that would be like IGES files or step files. Those are 3D solids. So let's look at an example of like a step file. So here's an example of like some step files. They look like 3D models because they are, but they are not program specific, meaning that if I had a step file like we're going to download from McMaster-Carr, I could open that step file in Inventor or AutoCAD or SolidWorks or Pro-E or Fusion or Creo. So you can take that IGES file or step file, and it is not program specific. So those are what I term dumb solids, and I'll show you why in just a second. Then the other side of that is we also have what's called an STL file, which you can use for 3D printing. That is what a lot of people refer to as a mesh. So a mesh is a little bit different than a step file or a 3D model. That you'll see what an STL file does is it takes your 3D model and it approximates it in thousands of little triangles. So, you know, for example, this is an example of an STL file. It's made up of thousands of tiny flat surfaces that you mesh together to give the appearance of a smooth 3D body. Okay, so any kind of 3D model that you would make can be meshed or turned into an STL file, but that's another example of a generic 3D file format. Okay, so these are used for 3D printing usually. They're called mesh files. They're like approximations of 3D models. They're not as clean as an IGES or a step file, but you can open them up in all kinds of different programs, and it's the file type that's used for 3D printing, if you're familiar with that. So let's go back and look at like a step file or an IGES file. So we're going to go back to our Ivy Learn page, and if you look in the week 12 folder, if we go down here, I've got a link to McMaster Car, which we talked about a couple weeks ago, which you may be familiar with. So if you go click on that link, it's going to take you here to McMaster.com. And you probably remember, we may have looked at this briefly in week 10, where you can download part models from McMaster Car. And I usually use it just for fasteners, but you can use it for other stuff too. So let's say we're going to go in maybe and download a U-bolt. These are kind of different. Let's see if we can get maybe one of these square U-bolts. They've got, yep, they got CAD models for these. So let's say I'm going to use one of these. Maybe I'm like mounting something or hanging something and I'm going to bolt it overhead. So let's say I need a specific one. So I'm going to go in, I need one that's maybe 4 inches wide and has 3 inches of thread on it. So I'm going to pick out of their catalog, I need this one, I need it to be zinc plated steel. Okay, so I click on the model number in McMaster Car, and you can do this for probably, I would say about 70% of McMaster Car's catalog has CAD models. Now if you pick out weird stuff like goggles or gloves or cleaning products, they don't have CAD models for that stuff. But raw materials, fasteners, general supplies, they have most 3D models for stuff like that. So if you click on the model number, you get this little icon that says Product Detail CAD. If I click on that, it takes me into kind of a spec sheet for whatever I've chosen. And if you go down, you get a finished CAD drawing for it. Okay, so you can download the 3D models for these things also. Remember, if you come down here, I can click where it says step file. I could also download an IGES file if I wanted to. And then you can see also they have like native SolidWorks files, which we can't open in Inventor really. But let's download the step file. So I'm going to click on that and hit save. And it opens up down here. Now, one problem people run into when they do this is they click on it in their internet browser and they get this, which basically this is Windows telling you, hey, I don't know what a step file is. I don't know how to open it. Now, that doesn't mean you can't open it. It just means that Microsoft Windows doesn't know what program to use to open the step file. So the way you get around this is if you go to Inventor after you download your step file, you can go to open and manually open it up in Inventor. Windows doesn't know this, but Inventor will open step files. So if you go to your downloads folder or wherever you save that file at, you can change your files of type down here. Instead of your native Inventor file types, I'm going to drop this down and switch it to all files, or you can do, step files or IGES file, whatever generic 3D file format you downloaded. So I'm going to go to step files because that's the one I downloaded. And there's my McMaster Car part model. I can open that up. And it will have to do a short conversion on this. So you'll see it does a little bit of thinking. It's going to pop up a menu here. I can hit OK and convert that over. It goes through the conversion process, which takes just a second usually. It's not too bad. It takes, 15, 20 seconds usually. And mine's taking a little bit longer because I'm recording video at the same time for you guys, but and we're getting close. There we go. So there's our finished step file. Now, the reason I call these dumb solids is notice over here you don't have any creation history for the way that this thing was made, meaning that there's no sketches, there's no hole tool, there's no thread tool, no fillet, no extrudes or revolves. It's just the whole thing. Here's the part, right? So you lose the ability to edit things. So step files are good for things that are already finished that you're not going to want to change. They stink for things that you need to go back and edit. So, we don't really have any ability to edit the way that this thing was created. It's frozen in time. So you get that with generic 3D file formats like step files and IGES files. You can change them further from here, like I can add things to them or cut things out, but I can't go back and edit the way that they were originally created. So McMaster Car is great for downloading some types of different things. So what I'm going to do, Let's go ahead and just close that out to kind of show the point there. I'm going to make a new assembly file, and I'm going to take this plate and throw it into that assembly file. So if you remember, our assembly files are .iams, so I'm going to go to English, pick a new standard inch assembly file, hit create. I'm going to go to the place button to throw my 6x6 plate in there, which I think is in my downloads folder. Yep, sample plate with holes. We'll go to open and throw that in there. Go to OK. There we go. So now I could take like McMaster car models and throw them in there if I want to. You can also use the content center. Hang on, my dog's barking. He probably needs fed. Just a second. Okay, I'm back. The dog has been fed. Okay, so we've got this plate, and we're going to go to the content center. So, you know, one option obviously is I can go to McMaster car and I can download step files or IGES files for nuts and bolts and washers and stuff like that. If you're going to do the McMaster car option, you know, I've got some of the different advantages and disadvantages here. So one thing I will note to you is if you're going to go to McMaster car, step files work the best. IGES files do work, but they cause some different issues. So I stick with step files. Okay, so I've kind of outlined some advantages and disadvantages here. So one disadvantage of McMaster car is that your parts don't update parametrically like the content center will. So I'll show you an example of that. One advantage of McMaster car, which is probably a big advantage, is it has way more stuff than the content center. So if McMaster car doesn't make it, it probably doesn't exist, or if they don't sell it. The content center and Inventor probably has 5% of the stuff that McMaster car does. There's just so much more in McMaster car. So I find myself going to this website probably more than using the content center. So now let's look at the content center. What's the advantage to using the content center rather than McMaster car? Well, one thing is that parts place themselves into different locations automatically. They update parametrically, meaning that if I change the size of a hole from 1/2 inch to 3/8, a lot of times the fasteners will read the hole size and they'll automatically update themselves also. So if you use the content center, parts update a little bit more cleanly sometimes, and it's less going back and forth between McMaster car to insert parts. So, you know, that's kind of one advantage. One thing that I hope they add in eventually is one of Autodesk's other programs, which is called Fusion 360, which you guys may be familiar with. It has a really, really cool feature that I hope they add to Inventor someday, where I'm going to try and show this to you guys. They have a built-in feature where you can go right inside of Fusion and drag parts from McMaster car right into your model. So you don't have to go through the catalog. Well, you do have to go through the catalog, but you don't have to do that process of like saving your step file and dragging it to the right folder and then opening it up and then placing it into your model. It's really, really cool that in Fusion 360, you just take the part model from the McMaster car website and drag it right into your CAD model, and it's there. So I think eventually we're going to see that in Inventor, but right now it's kind of a native Fusion 360 idea that Autodesk put in there. But since they make both softwares, it's probably not going to be too long till we see that start to show up in Inventor, maybe even in the 2021 version. We'll see. So I don't think, actually, let's look right now. I was hoping they'd put it in the 2021 version. It's not pulling up much though, so looks like maybe just Fusion 360 still. So hopefully in a future version of Inventor we'll see that come through, but for now we got to do it manually. So anyway, back to our model here. Let's go to the content center. So if we go to place from content center, this is the same process you'd use to place in any part model, you know, like you'd use right here if you made the part model. If it's something that's pre-made, you're going to go to the content center and it brings up Inventor's little pre-made hardware store where you can go in here and choose different things. So one thing that kind of stinks about this though is that you have to bring in each piece one at a time. So we've probably looked at this like in a couple weeks ago where we talked about fasteners, but I can go in here, for instance, and pick like a hex head bolt, which I'll go inches here. So let's go inch. It'll load in the actual model. I can click on whatever location I have. It will read the hole size out. And then it'll say, hey, I see this hole size on a bunch of other stuff. Do you want to auto drop it or not? And you can say yes or no. And you can drop it in there. Okay, so one thing that kind of stinks about the Content Center is I think it's a little bit slow. And if you need to put multiple hardware components in here, like if I want to have a bolt and a washer, and then on the other side I want to have a washer and a lock washer and a nut, I got to go into the Content Center 5 times then just to build out this one connection. So what I'm going to show you guys is how I can build a bolted connection without having to go into the Content Center 5 times or downloading 5 different parts from McMaster Car. It's just a little bit easier. So if you go to the Design tab, this is only in an assembly file. You can't do this in a part model. You have to do this at the assembly level in your IAM file. So I'm going to go to the Design tab, and I'm going to go to Bolted Connection. This is one of my favorite tools in Inventor. I don't use it enough, but it works so great. I love this thing. You do have to save your file first, just a heads up. So I'm going to save my assembly here. Let's just call it week 12 practice. Okay, so I'm going to go into the bolted connection button in my assembly model. And what I'm going to do is pick the start plane of where this thing goes. So I'm going to say my start plane is right here. Linear edge, I believe, is going to be a reference edge. Oops, sorry, I'm wrong one. I don't want linear, I want concentric. So let's change our concentric. So this tells it, okay, what start plane is the fastener going at? So I picked the top of our plate. The circular reference it wants to know is what hole are you putting this fastener in? So I'm going to pick, like, maybe, for instance, this one. Okay, that's where my fastener is going to go. And now the termination is where is the bottom of the connection. So I'm going to hit the arrow for termination, rotate this thing around, and pick the bottom. Okay. Now I can choose what diameter of fasteners do I want. So I've got a 3/8 hole, so I'm going to go with 3/8 fasteners. And now up here you can go click to add fastener. Okay, so I'm going to click this, and it's going to sort of pull me into the Content Center here, but I can choose multiple things all at the same time. So this is where the Content Center starts to pay off a little bit more. So it's going to load in here after it gets done thinking. These video recordings are kind of rough on my laptop. It's kind of beating its brains out here. Okay. Let's try that again. There we go. Okay, so it loads in the Content Center, and now I can choose what kind of fastener I want. So I'm going to go to bolts. Let's go hex head bolts. I'm going to pick something generic, so let's go with hex bolt -inch. I'll choose that. You can see it loads in a 3/8. I can hit that down button to go back in if I want to change it. I can hit these 3 dots. If this will work, let's see if my computer will open it. There we go. You can hit the 3 dots to choose the thread specification, whether you want fine thread or coarse thread. Now if I rotate around, lost my preview here. I'm going to add in a washer now. And you can see it knows I put a bolt in first, so now it defaults to washers. So I'm going to do a circular washer -inch. We've lost our preview here. Let me cancel out of this and come back to it. It should preview this as you go through and build it. Let me exit out and come back into this. So concentric, start plane, circular reference, termination, add a fastener. Sorry, you guys got to sit through this twice. There we go. Okay, hex head bolts. hex bolt dash inch. Okay, there we go. So we get a preview. You can see it extends down far enough where it just goes like one size in length past the termination point. So now I can hit click to add a fastener. I can put a washer underneath there if I want to, like underneath the head of the fastener. So I'm going to go down and do a plain washer dash inch. You can see it puts a washer underneath there. It's kind of hard to see, but it's in there. And now one thing that kind of confused me is I didn't understand for a long time when I first started doing this why it says click to add a fastener twice. So this is a little bit weird. Up here, this is the top of the plate. This double line right here in the middle, that's supposed to be your actual piece that you're bolting together, or multiple pieces. And then the bottom, if you add something down there, you'll see that it puts fasteners on the bottom. So I'm done on the top now. I've got my bolt and my washer. I'm going to go down to the bottom and put a washer, a lock washer, and a nut. So if I rotate this around now, using the bolted connection, I can go to add a fastener. I'm going to put another flat washer in there. So I'm going to go back to plain washer inch. I'm going to add another fastener now and put in a lock washer, like a split lock washer, to keep it from loosening on its own. And you can see now it thinks I want to put a nut on here, but I don't. I want to put a lock washer on. So I'm going to go back to washers and find some kind of lock washer. So let's go helical spring lock washers. And you can see this bolt is lengthening as I start to add stuff to it, that it will increase the number of threads on the bolt so that I have enough length on there to add all this stuff on there underneath. So very last, I'm going to go click to add a fastener, and let's put a hex nut on here on the bottom. Or maybe we'll get fancy. Let's do something different. Let's go with let's put a wing nut on there maybe. So let's go type A wing nut inch. Then we can hit apply. You can see it's going to build a sub-assembly here called bolted connection. I can hit OK. And down here at the corner, you can see it's like making all those pieces and constraining them together automatically for me. So not only would you have to bring all these models in from McMaster-Carr, you would have to go through and constrain all of them together also. So when that's done now, I can hit cancel. And you can see I've got my bolted connection if I drop this down with all my different parts in there. You can also go through and do this if I go in here and edit this. So I can say edit using design accelerator. I think I can do multiple holes at the same time also. Yeah, so if I pick more than one circular reference, I can go through and say, well, give me this same bolted connection at these different holes. And I can hit OK. And it'll go through and model them all. Now they all have to match, obviously, but and I've got kind of a design issue where these two are overlapping. But, you know, really quickly, what would take me a half hour probably of dropping parts in there and constraining everything, by using the bolted connection, I can put this series of fasteners inside this hole just in a couple seconds and copy and paste it if there's repetitive versions of that. So that's how you can kind of take the design accelerator and put it on steroids and maybe make it a little bit better than McMaster-Carr. So if you're doing common stuff, I like the bolted connection. If you need really weird, like specific fasteners, McMaster-Carr is still the way to go. It's a little bit slower and you got to constrain your parts, but they do have pretty much anything you can think of on the McMaster-Carr website. So that's kind of one versus the other. You basically have the old slow way with lots and lots of variety, or the faster, easier way with maybe not as many choices. So you kind of, unfortunately, there's no magic bullet here. You got to choose between the two. So that's kind of some tricks on importing fasteners. So just a way to make things a little bit easier for you and, you know, make them in handy on your final project. So that's all I got for you guys on the lecture video this week. Now remember, if you go to Ivy Learn this week, your homework is to start working on the final project. And to figure out more about that, you guys are going to go down below to the final project video and watch that, where I'm going to describe all the ins and outs of the final project, what you need to know, what you should do to get started. And so hopefully after our first week here, you've picked out something for your final project and you've gone ahead and started making sketches and maybe modeling some of the pieces. So your homework for this week is to start your final project and get as far as you can on it. So good luck. Watch the final project video. If you guys have questions, you can email me. jhamilton83@ivtech.edu, or call my office phone 317-917-5916. So good luck, and I'll see you later.